world, area, forecast, system. Significant weather charts provide information about flight. Critical weather phenomena at medium and high-level altitudes. These phenomena include the forecast locations of embedded cumulonimbus clouds, medium and severe clear air turbulence, jet streams, and other important meteorological phenomena. The WF's SIG weather charts are produced by two World Area Forecast Centers, or WFCs, London and Washington. The WFs are responsible for producing high-level SIG weather charts, that is between flight level 2, 5, 0 and flight level 6, 3, 0 for the whole world. They are also responsible for producing medium-level SIG weather charts between flight level 1, 0, 0 and flight level 4, 5, 0 for regions where there is a formal requirement for such charts. The WFs are not responsible for producing any low-level SIG weather charts. This is the responsibility of each state. We will now look at these SIG weather charts in some depth and understand how we can get maximum benefit from using them. Let's turn to the high-level charts. Each chart has a clearly defined legend, which contains the following information. The name of the WFC, which produced the chart London or Washington, a reminder that the chart is for a fixed time, the ICAO letter which is used to designate the area, the range of heights through which the chart is valid, the time in UTC and the date on which the chart is valid. WF's SIG weather charts are produced every 6 hours and are valid for midnight, 0, 6, 12 and 18 UTC every day. Since each chart is valid for a fixed time, it is the responsibility of the user to interpolate conditions between these chart times. The single letter which is used to designate the area of the high-level chart, H in R example, comes from the list of global regions which have been established by ICAO. An abbreviated name is sometimes used to designate this area rather than a letter, but this will not be visible on the legend of the high-level SIG weather chart. An abbreviated name is used on the medium-level chart legends. The other information which is displayed in the legend is largely self-explanatory, but a useful reminder that all height indications on the chart are in flight levels, all speeds are in knots, and CB, or cumulonimbus clouds, imply moderate or severe turbulence, ice and hail. This SIG weather charts, which are produced by WFC London, contain one additional legend. This highlights the flight levels between which clearer turbulence or CAT can be expected. In the legend, each area of CAT has a number. This corresponds to a numbered area on the chart enclosed by a dash line. Currently, WFC Washington SIG weather charts do not contain this additional legend. The CAT information is placed on the chart itself, directly adjacent to the associated CAT area. This format disparity will be harmonized shortly, and charts will follow the convention used. Welcome back to WFC London. Occasionally, you will see the abbreviation prob assigned to an area of CAT, which signifies a lower, yet still significant, probability of encountering turbulence during your flight. The legends used on medium-level significant weather charts are very similar to those you've already seen on the high-level charts. The main exceptions are the text lines, which clearly highlight that these charts are valid between flight level 100 and flight level 450, and that an area abbreviation is used to identify the chart region instead of an ICAO letter. Now, let's dive into the various phenomena you might encounter on WFC's significant weather charts. I'll be sure to highlight the key differences between the high-level and medium-level charts as we go. So keep an eye out for those. Let's start with one of the most critical phenomena, thunderstorms. Interestingly, thunderstorms are not explicitly labeled as such on the charts. Instead, they are implicitly forecast whenever a cumulonimbus cloud symbol is displayed. However, it's vital to remember that WFC charts only display embedded cumulonimbus. Open cell or isolated cumulonimbus clouds, which are typically easy to spot visually in the atmosphere, are not actually shown on these charts. This is because they are generally easy for a pilot to identify and avoid during flight. It is the embedded cumulonimbus, those that often remain hidden from a pilot until it's too late, that are specifically and clearly identified on our charts. As we discussed earlier, any mention of cumulonimbus or CB clouds signals the presence of moderate to severe turbulence, plus the risk of icing, hail, and the potential for thunderstorms. You will find additional, essential information tucked into the boxes assigned to each CB area. First, let's look at how the level of CB activity is indicated within those scalloped areas on your chart. We use ISOL to indicate that CBAs will be isolated within that particular region. OCNL is used to show that you might occasionally encounter CBAs in that area. WSPD implies that CBAs are forecast to be widespread throughout the scalloped area. And finally, we use FRQ to let you know that CBAs are expected to be frequent. These CB boxes also provide the specific flight levels where you can expect to encounter this cloud activity. If those flight levels fall outside the altitude range of the chart, you will see XXX used as a placeholder. For example, if you see ISOL EMBD CB, FL410/XXX on a high-level chart, it tells you that you can expect isolated, embedded cumulonimbus clouds. In this case, the cloud top is at FL410, and the base extends below the chart's lower limit of FL250. Moving on, let's take a look at tropical cyclones. These severe storms are marked on significant weather, SIG WX, charts with this easily recognizable symbol. That symbol is always paired with the name of the storm. In our example here, it's Olga. Tropical cyclones are typically associated with intense areas of cumulonimbus activity, which is sometimes highlighted on the chart with the letters FRQ.